Welcome to this introductory video on data analysis with RStudio. In this video, I will explain what RStudio and R are and how RStudio can be used to analyze data. I will also explain how you can make your analysis easier with the help of generative AI tools like ChatGPT. So first of all, what is R? R is a programming language which is used widely for data analysis, and RStudio is an IDE. You can think of an IDE as a collection of tools that makes working with a programming language easier. You do not need an IDE to work with a programming language, but with an IDE, it becomes a lot easier and far more efficient to work with a programming language. So RStudio is an IDE. You can download and use RStudio in your computer, but a better way is to use it online. Actually, not better, that pretty much depends on your preference. But there is a platform which offers RStudio online. So you do not have to install RStudio in your local computer. You can just go to this platform and use RStudio online. So this is the platform. It is Posit.Cloud. Go to this, and if you go to scroll down and click get started, you will see various options. So first there is the free version of RStudio, in which you can create 25 projects and you can use 25 hours of compute per month, and you can get an R of up to 1 GB, and you can get 1 CPU for maximum execution is going to be 1 hour, so on. So the free version is enough for students, but if you need to this more compute and more memory, then you can choose one of these packages that are available there. But for students, the free version is more than enough. If you do not already have an account, you will first sign up. But since I already have an account, I will simply log in. If you are using it for the first time, you will first sign up and then log in. Okay, I have already logged in with Google. I've created my account with Google, so I'll be using my Google account to log into RStudio online. It will take some time depending on the speed of your internet. So now I have logged in, and there is this option or button, new project. I will click it, and then there is and I will select new RStudio project. Okay, it will take some time to load and get ready, and we will have to wait for it. Now you can see that it is deploying an RStudio project. Okay, login successful, and now it will show us the RStudio in a few seconds. So we cannot do anything other than waiting. So let's wait. It is still working, and if your internet is okay, so it's how fast it will work will also depend on the speed of your internet. So this is the RStudio interface when you see it for the first time. It is the same interface which you will see if you have RStudio installed on your local computer. There will be 3 panes. One, this is console, then there is another, and then there is another. We will keep explaining as we move forward what these bands are and what is there in these bands. If you do not like the this arrangement and this color scheme, you can change it. You can go to tools and global options. For now, I do not have any issue with this arrangement. I just want to increase the font size so that it becomes a bit more visible to you people in the video. Okay, so I'll apply, and as you can see, the font size has been increased. So this is called console. You can see it is console terminal background jobs. So the console, and you can see a blinking cursor here. This is where the code will be executed. You can write the code here as well. So let's say we write 2 plus 2 and press enter, and we will get the answer 4. Similarly, we can let's multiply two numbers. For example, 3 multiplied by 4, and you get the answer 12. So you see, now we are writing something and we are getting answer. But this is obviously not what R is for. You can do these calculations simply in a calculator. We want to be doing better things with R. Okay, but before I type the next piece of code, I want you to see that this space here is empty, and in fact it says environment is empty. Now what I can do is that I can save certain values and assign them names. For example, let's say I want to save the unit price of X. Okay. So in naming variables in R or any other language, you cannot use spaces. So you will either use dot between words, or you will use underscore, or you will use the camel case in which the first letter is capital and then the following letters are small, or it could be either other way around. So I want to save a variable named unit price. Now I will use these two symbols, less than and a hyphen. This is called the assignment operator. There are more other assignment operators. For example, you can just type the equal sign or greater than and the hyphen symbol, but this is what I like. And actually writing equal sign, using equal sign is not advisable in R. So you will mostly use this assignment operator. See, this is called an assignment operator, a less than and a hyphen symbol. And I am going to assign it the value of 25. So the unit price of something is 25. Now when I press enter, you will see that something has appeared here. It is values, unit price is 25. Okay. If I reassign a new value to this variable, it will get the new value. For example, I will write again unit price, and now I have increased unit price to 30, and it will overwrite the first one. The first one will be overwritten. So if you assign some value to a variable which is already there, the earlier value will be overwritten without warning. Okay, so now our unit price is 30. Let's say now we save another variable which is quantity, and we assign it the value of 12. Okay, now you see a new variable has appeared here, quantity 12. Now what I can do is that I can call these variables and perform more operations on them. For example, I want a new variable which is total price, and I want it to be a product of unit price. I will write unit price, and when you are typing something, it will give you the options if from the variables that are already there. So you can select unit price from here, multiplied by quantity, which was our second variable, and press enter. Okay, so it has thrown an error, object quantity. Okay, we actually did I mean I mistyped the this variable. So this is quantity. Okay, so now you see the total price is 360. Total price is 360, which we have obtained by multiplying unit price, which is 30, and quantity, which is 12. Okay, again, if I manually assign a value to total price, or let's say now I go back and change the value of quantity to, instead of 12, I am going to assign it a value of 20. But you see, the quantity's value has been changed, but total price has not changed. So it does not work like Excel. If you have calculated a new value based on by multiplying two different values, and if you go back and change the value in one cell, the product will not be automatically updated. So that's not how it works. Okay, that is also that is something that you need to keep in mind. Okay, so I can assign single values to different variables, but I can actually create variables with more than one values. For example, let's say I want to create a variable student age, and I want to I want to write the ages of 3 students, 21, 22, and maybe 20, and I press enter, but I will get an error because that's not how it is done. If I am assigning more than one values to a variable, I will have to do something else. So I will just press the up button, and I'll go back to this line again. So what I should have done was actually to use this C function. This C function stands for combine. So if you want to assign more than one values to a variable, or you want to create a variable which has more than one elements, you should be using this function C, which stands for actually combine. So combine 21, 22, 20. Okay, and you will use brackets around the values. Okay, now press enter, and now you see student age variable has been created. It is 1, 2, 3, and then 21, 20 to 20. What does this 1, 2, 3 means? 1, the first value indicates the number of rows, and the second value indicates the number of columns. So this is a vector or a variable which has 1 row and 3 columns, as you can see. Okay, so now we have created a new variable student age. Now let's create another variable student name. Student name. And now I want to again write, because now I know that to use you know to create I mean to assign multiple values, I must be using C. So now I have written C, and now I'm writing the names of the students: Aslam, Akram, maybe Kinza. Okay, these are some of the common names in Pakistan. So I'm just assigning, I'm just writing those down. Okay, I have now written these three names, and I want to create this new variable student name, and I press enter, but again I will get an error. Let's see. Error, object Aslam not found. Okay, what is going on here? It is actually due to the fact that the values I am assigning are not numbers. These are strings or characters. So whenever you are assigning a string or character values, you will use double quotes around them. Okay, so now I will use double quotes around each value, which will tell R that this is a value and not the name of a variable. Okay. Now let's press enter, and now you can see this new variable has been created. So this is student age, student name. These variables have been created. Now you see the next problem. I mean, if I keep on typing this code in the console, after some time there will be a huge mess, and I will not know which code I wrote for which purpose. So this is not an efficient way of writing code. For that is why we have a better way to write code is to write it in a script. So you will, to create a script, you will go to this button here, the plus sign, and select R script, and this new pane will open. So what is this R script? I mean, when we write code in console and press enter, it is executed, and the output is also shown there. But the script is just like your code in a text file. You will keep writing your code, and then you can choose to run it line by line. It will not execute on its own, and you can always go back and edit it, and then you can also use it again. So this makes your code reproducible. You can share it with others, and you can do the same thing again if you need to. So from now on, we will be writing code in an in a script file. You can also save this, and I will give it a name. Let's say basic R script, whatever name you want to give it. It should be descriptive. And now you can see that in this file section, you can see a new file, basic R script. Okay. So let's do these things, copy this code to our script so that we can use it again if we want to. Okay, student name, for creating student name, and for creating student age. Let's copy these two pieces of codes. Okay. Now I can also write comments with these pieces of code, so that when I read those again, or if I share this script with someone else, they know what is going on, what each piece of code is. To write comments, you can use the hash symbol. Okay, I'm going to use hash symbol, create a variable student age. Okay, now you see, and then I am going to write another comment here, create a variable student name. Okay, when I execute this piece of code, the comments are not executed. Let me show you. I have placed my cursor here, create a variable student name, and I press this button run. You can see that create a variable student name has just been printed and nothing has happened. No variable has been created or anything. But the student name, this line of code was executed and a student name has been a student name variable has been created, but this is already there. Okay, to show you how this is done, I have all these variables in my workspace right now, but I can just remove them. To remove all of these, you can just use this broom. Okay, and it will ask you if you really want to do this, and I pressed yes, and now you see my environment is completely empty. All those things, that variables which we had created, are now gone. But now we have the script which we can re-execute again without having to write the entire code. So let's do this. Okay, run, and when I ran this, the first line being a comment was not executed, but the second line was executed and it created this variable for us. Now let's run the third line of code, but third line was again a comment, so it was not executed, but the fourth line was a piece of code, so it was executed and we got our new variable student name. Now let's create another variable. Create a variable student GPA. Now, okay, so we are creating a variable GPA, and we are going to assign values for all these. Let's say these are 3.1, 3.5, and then maybe 2.9. These are the variables of these three, the GPAs of these three students. Now execute this line of code, and now we have got another variable. Now these are three separate variables, but we are used to seeing data mostly in a spreadsheet sort of arrangement in which data is organized in columns and rows. Now I want to combine all these three variables to create a spreadsheet like structure, or a tabular structure. So what I want is that I want student's name in the first column, and then I want the second column which has student age, and the third column which shows the GPA of the student. So how can I do that? Well, actually I can. So now let's write another piece of code, combine variables to create a tabular structure. So now how to do this? Because we want to combine these into three columns, I can use a function cbind. But let's first give the new structure a name. So we want this to be called student data. And now what I am going to do is I am going to use a function cbind. Cbind stands for column bind. So you are binding columns. So what I am going to do is to first write student name, then student age, and then student then is GPA. Okay, now let's execute this line of code, and as soon as you did, you can see that something has appeared here, student data, and it is not values, but it has the heading of data. And now you can actually see that when I hover the cursor over it, it suggests that it is something clickable, and so I click it, I left click it, and a tabular structure has opened. So now you can see that we have a tabular structure which is student name, student age, and GPA. Well, that's what we wanted. So it has been created. However, there are a few more things to see now. One of them is that all these variables, now we have these variables, a GPA, student age, and now we have a new object which we created by combining these variables. These have different types, and we want to check the type of these variables. Okay, so now let's check the type. Check class of check class. Okay, now let's see. So what the function I use to check the class of an object is simply class. So let's class GPA, and I also want to check the class of student age. I also want to check the class of student name, and also class of student data. Okay, now let's run these pieces of code one by one. So the class of GPA is numeric. Good. Now let's the second line of code. The class of student age is numeric, and the class of student name is character, because this is the character, and the class of student data is matrix array. So this is the problem, because if you remember from some introductory classes on algebra, an array is it does not have headers, okay, but we want data in a format where the columns have different headings, and just like we are used to seeing data in Excel spreadsheets. Okay, so that sort of an object which has column headings is called data frame. But this thing here, this object here, is not a data frame right now. So I need to convert it into a data frame, because that is the class or the type which is mostly used. So now what I can do is that I can coerce the class of an object to change it. Okay, so which means that I can change the class of an object by coercing it. So let's do that. To do that, what you need is that let's create a new variable. It is actually the same variable, student data, and I will write as dot data frame, and I will use this student data object, student data object. So what I am doing here is that I am taking student data as it is right now. I am coercing its class by into data frame. So I'm using this function as dot data frame. So what this piece of code is doing, that it is saving student data, the current student data object, as a data frame into a new object which is also called student data. So what it will do is that it will change its class into a data frame. So let's run this piece of code, and now you can see as soon as we ran this piece of code, this button here has appeared, suggesting that probably its class has changed. But let's check it again. We can run this piece of code again to see what is the class of student data. So now you can see that class of student data is data frame. So great. I mean, we have changed the class of an object. You can do that with any object. Okay. So let's write a comment here. Change the class of student data to data frame. Okay. Once you have data in a data frame, you can check its properties. Okay. So whenever you have a data frame, you import it into R, you probably want to see how many columns and rows are there. Okay. So to check how many columns or rows are there in a data frame, you can use the function dim. So now let's see, check the dimensions of the data frame. To check the dimensions of a data frame, because we have this data frame now, so we can work with it, we can use the function dim, which is short for dimensions. Dim student data. Now let's execute this piece of code, and it tells us 3. So there are 3 rows and 3 columns in this data frame. Okay. We also want to see which columns are there in this data frame. So if we want to see what is inside a data frame, we can use another function which is very, very useful. Okay. So let's see. Check the structure of data frame. Okay. To check the structure of data frame, you use the function str, which is again the short for structure. Data, sorry, it's not data, it's student data. Now let's run this piece of code, and we get this output. So this tells us that we have data frame str student data. It is a data frame, 3 observations of 3 variables, it has 3 columns: student name, which is a character variable, Aslam Akram Kinza, student age 21, 22, and it is also character, and GPA, which is also character. So you see the problem here. I mean, the names should be character, but the student age and GPA are not supposed to be characters. These are numeric values. So again, there is a problem. We have variables inside a data frame whose class is not correct, and we will need to change that as well. So that will require accessing a single column inside a data frame and then changing its class. So how to do that? To access a column within a data frame, you can use a $sign. Okay, so now let's see. What we want to do is change the class of GPA. So how we are going to do this is that we are going to use student data, use $sign, and as soon as you type the $sign, the names of columns will be shown to you. And now let's select GPA, and now let's assign it a new value. So we want to save this as numeric. Okay, what are we going to save as numeric? We are again going to use student data, $sign, GPA. I want to explain this code before executing. What we are doing is that we are accessing the GPA column within student data frame as it exists right now. Then we are saving it as numeric. And where are we saving it? We are saving it again in student data GPA column. Okay, I can create a new column and save it there, but that's not what I want. So what I am doing is that I am taking a column in a data frame, I am changing its class and saving it in the same column. Okay, so now let's execute this. Okay, now let's check the structure of student data again. Now when I run this, now you see that the GPA's class has been changed to number. GPA's class has been changed to number. Fine. So I will also need to change the class of age. Okay, so now let's do the same again. Student data $, student age, as numeric, again student data, and within student data we have student age. Okay, now let's run this, and now as we have run this, now let's check the structure of the data again. Okay, great. Now you see that the student age is also numeric, GPA is also numeric, and student name is character. So that's how you change the class of an object. And not only you can change the class of an entire object, but you can also change the class of certain variables within a data frame. So far so good. So far we have seen how to see the dimensions and structures and how to change the classes of certain objects. But to analyze data, we usually have data in some other form in very huge volumes. We will probably need to import it into RStudio and then analyze it. So let's do that here as well. Okay. So what we are going to do now is to import our data set from a CSV file. Okay. Because we are using this online, I will first need to bring that CSV file into this environment. But if you are using RStudio on your local computer, you can just give the path to that file on your local computer. But since I am not using this on my local computer, I am using it in an online environment, so I will have to bring that file here as well. To bring that file into this environment, I will use this button upload here, upload, and I'm going to choose some file from download. I have it there, and now I am going to upload it. I have this file here, suppliers underscore data dot CSV. Okay, I want to save it as supplier data, and to read a CSV, I use a function. I can use a function read dot CSV. After read that CSV, I am going to give the precise name, and all languages are case sensitive, so I'll have to make sure that I type the precise name. Suppliers data's D is capital dot CSV. Let's see. Now let's run this, and you can see that supplier data file has been created. A new supplier data file has been created. Okay. Now I want to see the dimensions. Okay, check dimensions. So I'll use the command dimension supplier data. Okay. So this tells me this is 400 by 21. 400 by 21 means there are 400 rows and 21 columns. Fine. What are those columns actually? Okay. So there are a few ways in which I can see that. I can use structure, and I can also use another way, which is head. Okay. I want to see top rows of data. Okay. To use the top rows of data, I can use the function head. So head supplier data. When I run this, it gives me actually, okay, you can just see that it gives me, what it is giving me is that it is giving me column names and a few top values, 6 top rows. Okay, out of 400 rows, it is showing me the first 6 rows, so that I can see what is there in the in each column. So supplier ID, category, and I can see that in category I have printing and ink and adhesives and chemicals. In cities I have Ahmedabad, Karachi, Jung, Turbat, delivery delays, so on and so forth. So this is one way of seeing what columns are there and what kind of values are there in each column. The second way to do this is to okay, is to simply click this data set here, okay, and it will open here, and you can see it as you would a spreadsheet. So I can see that the first column is supplier ID, the second is category, the third is city of the supplier, and then we have delivery delays, how many delays have we faced from this supplier, consistency, which is a rating of high, low, rejection incident, how many times the deliveries from this particular supplier has been rejected, compliance with specification, high, moderate, low, again some categories, average response time is, this is maybe 41, this is probably in hours, issue resolution rate is in percentage, length of partnership or partnership with this particular supplier, 5 years, 16, 4 years, past performance trends, declining, improving, declining, stable, order fulfillment rate, lead time, compliance, scalability potential, price fluctuation, competitive pricing, how competitive the pricing of a supplier is, and then the distance, and then transportation methods, and payment terms, flexibility, credit terms, what kind of credit terms this supplier offers, and then we have a label at risk, reliable, at risk. So we have classified these suppliers into at risk and reliable, etc. So this is the second way of seeing what columns are there and what type of values are there in each column. Okay. Now there is another way which we have already discussed. We can see the structure. Okay. You can always adjust these the size of these pans. So I am just going to use what am I going to do? Check the structure of supplier data. So I am going to use this function str and of supplier data. Okay. So now you see that it is telling me, it is showing me what columns are there, what the type of or the class of each column is, and what kind of values are there. So this is very important, and here comes and now using this information we will bring in generative AI to help us do the analysis. Okay. So if you do not know what kind of analysis you can perform, you can simply copy the output from this, okay, including the piece of code, this str supplier data. I am just going to copy this from here. I am going to go to ChatGPT and I am going to paste it here. Now when I give this to ChatGPT, now the ChatGPT knows that I have this object, supplier data, this is the type, these are the columns in this data, these are their types, these are the sort of values it has, okay. And now ChatGPT will know what the structure, what the name of my data object and its structure are. And now I can ask it for help with analysis. So I am giving this to ChatGPT. This is the structure of my data. What type of analysis can I perform on this data? Okay, let's ask ChatGPT and it will tell me what I can do. So it is telling me you can do descriptive analysis, for example, summary statistics for numeric variables like delivery delays, average response time, etc., frequency distribution for categorical variables like category consistency, scalability potential. It also tells me that you can do cross tabulations, frequency of label category, supplier performance analysis, blah blah blah, correlation. Okay, so predictive modeling, graphic analysis, so the geographic analysis. So these are quite advanced types of analysis. I just want to perform descriptive analytics. Okay, so I ask it, give me the code for creating summary statistics of what was it suggesting? For this was delivery delays, summary statistics of delivery delays. Okay, you can use the following R code to generate summary statistics for delivery delays. Okay. Okay, so this is summary supplier data delay. Okay, and then it is also giving me some extra code, additional statistics, mean, median, ST, minimum, maximum, quantile, blah blah. So I really don't know what these are. So one way is that you can simply copy and paste the entire code into R, but if you have some understanding of what is going on here, you will know that what this code is about. So that is why some basic understanding of R is necessary. So I can see here that additional statistics are mean, median, etc., and then NARM. I mean, I really don't know what this is for. I mean, this code is probably enough for me. So I will just copy these two lines. One line is actually the comment and the second line is the actual code. I will just copy it from here. I will go to my script and paste this here, and I will simply run it. And as soon as I ran this, I have got this output. So the minimum in delivery delays is 0. First quartile is 1, median is 3, mean is 4.195, third quartile, and maximum is 14. So now I know that maximum from a supplier we have got 14 delays. The mean value of delays, that is what we generally refer to as average, is 4.95. Median is the number below which there are 50% of the observations, and the first quartile is the point below which 25% of the observations lie. So 25% of our suppliers have less than 1 delivery delays. Similarly, third quartile, 75% of our suppliers, third quartile means 75%. 75% of our suppliers have less than 6 delivery delays. Okay, fine. Now I want to ask to get the code for a histogram. Give me the code for creating histogram for delivery delays. Okay, so this is giving me the code. Histogram for delivery delays. Even if I don't understand this code, I can simply copy it from here, paste it here, and run it. Okay, now let's do this. Histogram is okay, and when I ran this, I am getting something here in this section, in the plot section. So now you can see that I have this histogram here. I can zoom it. Okay, I can export this as a PDF or save it as an image, or I can copy it to clipboard. But if I don't like this, and I obviously don't like this, and this is a funny looking histogram, I can change I can ask ChatGPT to change, for example, the color. Okay, so I am going to ask it to change the color of histogram. Okay, it will give me a new code by changing the color. I don't know what this code is. I will just copy this, and I will replace my existing code with this new one, and I will run again, and now you see its color has been changed to red. Great. So now I have used ChatGPT to write code for me and run it, and now it is helping me do things. Okay, let's ask ChatGPT to do some more analysis for us. So now you see the problem. ChatGPT can help you, but you must have some understanding of both the statistics, what kind of analyses are there, what kind of graphs you can create, what everything means. What median or mean or third or first quartile mean. If you do not have this understanding, then you are going then you are going to face problems. You must have this basic understanding, and you must also have some basic understanding of our syntax and how it works. So that is why I explain the basics at some length. Okay, so the more you know about things, the more you can the more useful AI will be for you. Okay, so you cannot delegate entire task to AI, at least for now. You must have some basic understanding, and then you can help then you can use ChatGPT or any other AI tool to help you. Okay, anyways, let's create. I want to see how many of how many suppliers are let's see what was the column. Let's see that. Okay, so this was category. Okay, in each category, how many suppliers are there in each category? I also want a pie chart for this information, whatever you want to know. Okay, you can use the following R code to count the number of suppliers in each category and create a pie chart. Okay, I'm just going to copy this piece of code. I'm going to paste it here in my script file and simply run it. Okay, so you see, this is count the number of suppliers in each category. Let's run this, then print the category count. So if let me adjust this. So this is telling us that we have adhesive and chemical. In adhesives and chemicals we have 37 suppliers. In logistic and distribution we have 56. Machinery and equipment suppliers are 82, and the number of other packaging component suppliers is 42. Printing and ink and raw material suppliers are 122, and printing and ink suppliers are 61. Okay, so that's good. Okay, now let's go back to the next piece of code and let's run this for pie chart. Okay, this some chart has been created, but oh, it looks very funny. Okay, so you see the chart is very small and the labels are huge, so this chart looks funny. So I'm going to ask ChatGPT to refine it. Okay, so maybe I'll just ask it that the pie chart looks funny. It has huge labels with small chart area. Okay, so let's see what it gives us. So now it is giving us adjust the plot size and label text, pie category count, etc. Okay, I don't know what changes it has made. I will just copy this code and replace the existing code and run it again to see if it makes any difference. So not much difference. Okay, this is still looks funny, although the font size seems to have decreased. Okay, now maybe I'll ask it to know, don't use labels, give labels as a legend. Okay, now let's see if it can help us with this. Okay, so I'll just copy this and paste it again, and okay, so I'm going to use pie chart. Okay, this is still very small, and now I am using legend, so this is added on this side. Okay, this is much better, but the chart area is still very small. Okay, so I'll just ask it to the chart area is still very small, increase it. Okay, okay, so now it is giving us something, a new code, and we will just copy this piece of code again, and okay, paste it, and let's run this piece of code again. So maybe it is adding some parameters. So parameter pie. Okay, I think this is not working due to okay, now let's maybe error in function user null for invalid graphic state. Okay, so maybe this is not showing, so I'll ask ChatGPT again that it is not showing. Okay, the pie is not adjusting metric, resizing, plotting window. Okay, maybe it did something. Maybe it increased the size too much, and now it is not available. It cannot be seen. So okay, so let's open function only RStudio graphic devices warning message, pie, error in plot, new plot, region too large. Okay, the plot region too large. Now let's say I will copy this error code and give it to ChatGPT to adjust it. Okay, preventing multiple graphic device from opening the plot region 2. Okay, maybe dev off parameters CCC. Now it has changed code again, and let's see if it works now. The point here is that you can use ChatGPT to iteratively improve the code and do something. Okay, now it is visible, and now let's add legend, and it is now visible, and now we can see this, but now the legend is is covering the our pie. Okay, so this is the new problem, and maybe we can simply ask ChatGPT again to help us overcome this problem as well. So this is how you can give iteratively refine your code by asking ChatGPT to make it better. Maybe if you get some error, giving it back to ChatGPT, and it will refine the code further and further for you. So after a few iterations, you will get what you want. So that's how you can use ChatGPT to help you do the analysis in R. So that's all in this video, and I hope you will find this helpful, and for more videos like this, please subscribe to the channel.